Hi, Assalamualaikum. So today I'm going to talk about lab 5. Uh, for the first one, we have to initialize the data clock and latch pins. So here we have 2, 3, and 4. And then for this one, we use for LED manipulation, which is LED state is at 0, which is off. And then for on, we put it as constant on high. And then off, we put as off equals to low. So for Arduino, we have to use high and low for the states of the output. So here we just initialize it as on and off. So at voice setup, we have pin mode, data, clock, and latch as output. So today I'm gonna talk about my part, which is the update LEDI, which is this one. So which is So for here, we decided to put the delay time as 100, which is the millisecond for the delay between each LED. So here we have a counter for LED for the LED. So for here, INTI is equals to 0, which is all of the LED turned off. And I equals to 256. This is because we have to put it in binary number. So 256 is equals to 1111111 8 ones. So this number is to turn on all the LED, and then this one we have I plus plus, which is the counter. So in update LED, we have this coding, which is NT value, which is from 0 to 255. 256. So this is the right latch low, and then we put shift out data clock MSB first value. So this is to shift out the 8 bits of the integer into the shift register. And then we put the digital right latch high. So this will put the latch high and display the data, which is the LED lah. So that is all for my part in this lab 5 group video. Thank you.
Okay, for my part is the second part, which is for the update LEDs long. Update LEDs long have the same pattern as the update LEDs, which it will turn on the LED according to the binary, starting from 1 until 256, which is all LEDs, which is equals to 11111111. So the difference is the codes for the update LEDs long. It is longer than update LEDs because it is not using the shift out. The shifting out is done in the software. Hence, it will need the for loop, initialize the bit to save the value when there is the mask bit mask. Then it will shift the value. And next is the if condition. For example, if the value is 1, it is equals to in binary 000000001. Hence, the bit will not after the mask, the bit will be 0000000 because the ones is not at the same number of bits, and this is use the AND logic. Next, the value will be shift and the number will be up by 1 bit value, so next time the bit 1 will be bit 2. So the process will be repeated until it meets the condition. It will repeat for 8 times, once for each bit, until it meets the condition and until all the bits have been repeated. So after the after the value have been shift and the mask have got the value, the bits have got the value of the mask, it will enter the if condition which is 1 to 8 is equals to 1000, and then the data will be set to hide, and then the latch will store the data and set the LED to lights up according to the binary bit of the number of I. I equals to 1, so the binary bit is 1. If I equals to 2, so the LED will be set to at the binary bit 0012. So the second LED will be turned on, and so on. If the I equals to 3, it will be turned on 2 LEDs. Equals to 4, it will be turned on at the third LEDs, which represent the binary. I equals to 5, it will be like this, and the result will be seen after this coding video. Thank you, that's all from me.
Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Muhammad Haziq, and before I start with the continuation of the video, I would like to apologize if you may hear or heard noises in the background. This is because I'm currently at the hospital for my checkups, and I apologize for any inconvenience caused. So back to the video. Before anything, we will have to go through a bit of a revision to allow us to be familiar with the circuit of this lab. So considering the lab manual does not specify which logic gate is being used in the IC, but with our observation, it can be seen to be using the simple ones, which are AND and OR gate, since it's a masking binary. So the coding that's been used for the array will be shown on screen. As per observation, the coding is used for on loop is given a value from 0 to 8 to run the array one by one, and the same is used for off loop. So the complete coding version for this part can be obtained from the lab manual, and for this part we will observe the on off situations of LED using the AND and OR logic gates. So in the coding, there will be an abbreviation of LED state, which will be used to state LED for the function update LED to ensure the LED will change according to the input binary. So for starters, the initial state will be all LEDs off, which means the binary will be 000000, and then we will start with the current state as mentioned earlier, tallied with the OR condition, which is if any is 1, it will come out as 1. So at array 0, it will come out as 0000001. Hence the current situation will be as said just now. And we will continue the process until array 8, and the LED state will eventually come out as 11111111, and it means that every LED is on. So when we are turning it off, we are not going to use the OR condition, but we will be using the AND condition, which needs both to be 1 to produce 1. So with the current state of 11111111 meets with the AND condition of array 0, it will come out as 1111110 as the new LED state. So this means that we will turn off one LED on its one by one until we turn off every LED, which will eventually come out as 0000000. So the process is repeated from array 0 to array 8 to ensure that every LED is turned off. So that's just a bit of this part and a bit of a revision for those who may have forgotten about the simple array and simple logic gate usage for the IC. So the results will be shown after this, so I hope you guys can stay and watch the simulation or the video for this part, and the results will be shown later on in the video. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.